Hello friends. So last topic of solution আমি discuss কৰিলো. So solution chapter that আমি four concentration terms or বিষয় আমি পঢ়িলো. So আজি আমি fifth concentration terms or পৰা start কৰিম, that is mole fraction. So mole fractionক represent কৰো a symbol টোৰে. A symbol টোক আমি কি বুলি কওঁ generally, but আমি normally x symbol ৰে ইয়াক represent কৰা হয়, just representing x. So normally it's represented by chi. So as is it we express mole fraction, it is one of the most important concentration terms. Practically it has no units because it is a number only. So it is a general description. It is very simple. It is defined as the ratio of number of moles of one component. That means we already told you that we only discuss binary solution. That means binary solution having two components, solute and solvent. So each component or number of mole fraction calculate koribo paro. Also definition to hetu upor depend kori ami derive korisu. So it is defined as the ratio of the number of moles of one component, it may be solute or solvent, to the total number of moles of all the components present in the solution. That means jikono eta component or number of moles or লগত যদি আমি ওভারঅল সলিউশন টু নাম্বার অফ মোলস রেশিও ক্যালকুলেট কৰো তেতিয়া হলে সেই কম্পোনেন্টৰ আমি কি পাব পাৰো, মোল ফ্র্যাকশন পাব পাৰো. ইট মে বি নাম্বার অফ সলিউট টু দা টোটাল নাম্বার অফ total number of moles of solution. It may be number of moles of solvent to the total number of moles of solution. So total number of moles of solution or to ki hobo solute aru solventor overall jeto number of moles hobo. So yet ami mathematically express korisu. So if AB is a solution, jodi ami AB eta solution boli dhau orthat A aru B ami ekane loisu, so eta ka ami solute ba eta ka ami solvent hisabe express koribo paru. So ekane duta component ami separate ke express kori rakhaisu. So then number of moles of A, suppose Na, number of moles is Nb. So mole fraction of A can be represented by, so I already told you it can be represented by x, but generally it represented by chi. It is a symbol. So but we denoted only x. So mole fraction of A is xa, so mole fraction of B is xb. So we can define mole fraction of A and B. That means maybe solute or solvent. It may be solute or solvent, it may be also solute or solvent. So according to question we can change solute and solvent. So for let's discuss. So mole fraction of A, so that is represented by xa. So it can be represented, it can be defined by formula according to the definition. So number of moles of A to the total number of moles. So Na plus Nb. So two components are present. So number of moles of A, number of moles of B. So when we sum up, we get total number of moles. So number of moles of A to the total number of moles. Similarly, mole fraction of B is to number of moles of B to the total number of moles of solution. So this is the general description or general way to discuss or deduce mole fraction. So it is very important that the mole fraction of a solution never exceeds 1. That means it is equal to 1. So if we find xa and xb, that mole fraction of A, mole fraction of B, then if we summed up the value, then it will always be equal to 1, approximately equal to 1, or maybe directly equal to 1. So that is the total mole fraction of a solution is always unity and temperature independent. So that means the temperature level dependent now. So the temperature increase but decrease kore mole fraction change hoba noka. So mole fraction jiman thake imane thakibo, and it is very important there is a no unit. Okay, so there is no unit. So so let's discuss. Sorry for the background music. So let's discuss one question. So this is the question. So in this question express, calculate the mole fraction. Calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. So it is very simple because this question already discussed in this question also asked in your NCERT books in text questions. So in this question given, so enoka question koribole jaote hoday ami question to ki dia ase hetu bikhoy ami express kori lobole. So jodi ami express kori sao, so in this question you see mass of the solution, that means 30% by mass means the mass of solution, that means W solution always be equal to 100 gram. Okay, that means in 100 gram of solution according to definition. So by mass means W by W percentage will be given. That means if the solution is 100 gram, then the 30% denoted that the W solute will be equal to 30 gram. Okay, so mole fraction of benzene in carbon tetrachloride solution. So that means in this question, benzene is the solute and carbon tetrachloride is the solvent. So this is mass of the benzene. This is mass of the benzene. So we have to find mass of the solvent, that means mass of the carbon tetrachloride. So mass of the solvent will be solution minus, so 100 minus solution minus solvent. So already we know that solution is solvent plus solute. So thus we get the 70 grams. So 70 gram is the mass of carbon tetrachloride, CCl4. Okay, so this is we got from the question. Then already solute is benzene, so we have to require molar mass of the solute. So we already known as M solute. You have to find. So M solute means for benzene. Okay, C6H6 for benzene. So benzene have 6 carbon, 6 into 12 plus 6 hydrogen, 1 into 6. So gram per mole. That is equal to 6 12 72 plus 6 is 78 gram per mole. So this is the molar mass of benzene. So then we already know that so it's a long question normally. So then we find out, because for calculation of mole fraction we have to find number of moles. So therefore number of moles of solute. So solute is what? Benzene. So benzene, that means weight of the solute divided by molar mass. So weight of the solute divided by M solute. So this is the formula. So that is W solute is 30 gram and molar mass of the solute is 78 gram per mole. And if we divide, then we find the value approximately equal to 0.3846 mole. So one number of moles value we can already calculate it. So we have to find now a number of moles of solvent, that is carbon tetrachloride. So we have to now find the molar mass of carbon tetrachloride. Already mass we already know that weight 70 gram. So we have to find molar mass. So now we have to go. So let's take 1 minute. Okay. So we have to find mass of the, that means we have to find molar mass. So M solvent, that is already we know that CCl4. So 1 carbon 3 chlorine, so 1 into 12 plus 4 into 35.5. so this is a relative mass of chlorine. That means 2 isotopes of chlorine are present, one is 35, one is 37. So if you take ratio, then you find average value 35.5. so overall value will be 154 gram per mole. So we got the mass of the solvent. So number of moles of the solvent, that is carbon tetrachloride. We know that weight is 70 gram. Molar mass already we deduced 54 gram per mole. So then if we do the solution, we have got the value approximately equal to 0.45. It is repeated, so that is the number of moles. So according to question asks mole fraction of benzene. Okay, so therefore mole fraction of benzene C6H6. Benzene is the solute, so number of moles of solute, mole fraction of solute to আমাক উলিয়াব কৈছে. So number of moles of solute divided by number of moles of solution. That means total number of moles of solution. Solution will be solute plus solvent. So number of moles of solute will be 0.3846 divided by number of moles of solution will be 0.3846 plus 0. This is the number of moles of solvent, so 4545. So if you do the problem, we got around the value will be 0.45 8 approximately. This is the mole fraction of benzene. So according to question, they asked next question to calculate the mole fraction of benzene in solution containing 30% by mass in solution. So we also find the mole fraction of carbon tetrachloride, but you do the part. So this is mole fraction. Now we go to next concentration terms, that is molarity. So it is very important. Molarity. So molarity is nothing. It is a ratio of number of moles of solute to the volume of the solution. So it is a just description of a simple ratio. So that means there is a definition. So it is defined as the ratio of number of moles of solute to the volume of the solution in liter. So molarity is expressed by capital M. So that means the first alphabet represents its terms. So it is nothing. It is a ratio of number of moles of solute present in a 1 liter solution. If you describe in a proper definition. So it is just a definition of number of moles of solute to the volume of the solution. So volume of solution should be present in 1 liter. That means in 1 liter solution of the volume, 1 liter volume of the solution contains number of moles. So that number of moles expresses in terms of molarity. It is a ratio. So it's very simple. If you do the problem, then you got the brief application of this molarity, because in every cases when you make the solution, we have to make basically in presence of molarity or other terms also present, but normally molarity terms are used mostly. So it is according to definition, we can deduce mathematical formulation. So molarity represented by capital M. So number of moles of solute present in volume of solution in 1 liter. That means 1 liter of solution. So from the definition, we got the unit mole per liter. Okay, so this is the unit of molarity. So this also represented, also I will tell you later. So you can deduce this mathematical formulation to a simple derivation formula. So let us consider W solute is the amount of solute, M solute is the molar mass of the solute, V sol is the represented as volume of solution. Then number of moles of solute will be W solute divided by M solute. You already know that our weight divided by molar mass. So if we put these values in this form, then we got this in the form. So W solute, M solute multiplied by 1 by volume in liter. So we can convert it liter to milliliter. So we got this W solute M solute 100 divided by volume solution, and we can deduce the unit also. So weight represent gram unit, molar mass unit is gram per mole, and solution in ml. So if you convert it to already it is present in liter, so when you convert it to ml, so 1000 is come here, so ml per liter, gram per ml, so 1000 or logot ml per liter unit thake atkile thake solution of lazy to liter to ml le convert korile ami etu pao. So similarly, if you put this values, then we get the mole per liter. So same unit got in both cases. First definition directly indicated the unit. From if you simplify, then again we find the same unit. So unit will be in mole per liter of molarity. So it can also be unit represented by capital M. So 1 molar, just as example, 1 molar, 2 molar, 3 molar can we express. Okay. So it's very simple. So this is molarity terms. So then we again go through some questions. Some questions are present. So first question, we take this. Calculate the molarity. Okay, calculate the molarity. Very simple question already we take. Calculate the molarity of 20.6 gram sodium bromide dissolved in 500 ml of solution. So here namak ki dia ase, atomic mass of bromine will be 80 gram. So bromine atomic mass dia, sodium already we know that 23. So given ki dia ase amak given dia ase WNABR, that means weight of the sodium bromide or diasema. So that will be, so this is W, okay, sorry, that will be 20.6 gram. Okay, so then namak diya ase kya, volume of solution diya ase amak 500 ml. Okay, so we have to find molarity. So number of moles of solute level was solute sodium bromide. So molar mass of the sodium bromide we have to find MnAbr. So sodium will be 1, so 23 plus 80, that will be 103 gram, actually gram per mole. Okay, this is the molar mass. So then we put the formula, solution of volume diya ase. So according to formula, so we know that, just like we know that molarity ami keneke uliam, M will be W solute, ami formula to ki jano, divided by M solute, already we deduced, multiply by 1000 gram per liter, sorry, not gram, ml per liter, divided by volume of solution in ml. So already ml present, so W solute we have to gram hoy, so amak 20.6 gram divided by molar mass will be, already we find 103 gram per mole, multiplied by 1000 gram per liter, divided by volume of solution will be 500 ml. So if you do the problem, if we solve this problem, then we got the answer approximately equal to 0.4 gram cancel, sorry, this is again gram, ml, so ml cancel, will be mole per liter, or just you write 0.4 capital M. This is also the answer. This is the solution, that means 0.4 molar of this solution. So very simple. So actually আমি বস্তুটো এক্সপ্ৰেছ কৰাৰ ওপৰত ডিপেন্ড কৰি আমি কেনেকৈ এক্সপ্ৰেছ কৰিছো. Okay, so this is question number 1. So another question already we take, question number 2. So calculate molarity of pure water of its density 1 gram per ml. So pure water or density dia ase ami molarity uliaba lage water kya. So ami ate solve korim. So ki dia ase ama call question amak dia ase ama pure water density uliaba lage molarity uliaba lage. So density of pure water amak dia ase density of water amak ki dia ase ama 1 gram per ml. So ito amak data dia ase. So simple data dia ase. So ami answer uliaba lage. So normally ki thake volume of solution. So molar mass hodai 1000 ml of water uliwa hoy. So 1 liter solution ami calculate koru. So ami dhori lobo lebo. So we have, so we know that, but let us consider volume of water will be 1000 ml. Okay, so this is basically when we calculate the molar mass, that will volume will be 1 liter, that means 1000 ml. So volume will be 1000 ml. So we have to find molar mass of water. Mass of water we can find first. Molar mass already we know that 18 gram. So mass of water, that means H2O will be so already we know the general formula. So density equal to mass by volume. Okay, so mass will be density into volume. So this formula we use here to reduce the mass of water. Okay, so mass of water jodi ami uliabole jao, so ki hobo mass of water. So yata ami likhi lobo paru mass of water, that is WH2. Mass of water will be density 1 gram per ml multiplied by volume. Volume will be already taken as in water 1000 ml. Okay, so ml will be cancelled, so gram will be 1000 gram. That is mass of water will be 1000 gram. So molar mass already we know, we know that means 2 hydrogen 1 oxygen, so that is equal to 18 gram per mole. Okay, so molarity আমি যদি ফর্মুলাত বহাই দিম, molarity উলিয়াবলে যাও, W solute M solute multiplied by 1000 ml per liter divided by volume of solution in ml. So simple ml ola ami consider korilu. So volume of water kiman asile, solution means that solution to ki water kothai goise amak. So solution means water kotha express korilo. So W solute will be 1000, already we calculate 1000 gram, divided by molar mass will be 18 gram per mole multiplied by 1000 ml per liter. Okay, divided by volume of solution will be same 1 liter, that means 1000 ml. So ml cancel, gram cancel, 1000 cancel. So 18 divided by 1000 will be 55.55, so mole per liter. So that is equal to 55.55 mole. So this will already we find in class 11 also. It is very important. So chemical equilibrium ami water ami molarity ami calculate kor pure water. So it again we deduce here. So this is the molarity of pure water and density. So pure water is so no mixing. So water also behave as a solvent. So let us call it a solvent. Okay, I express question. So no question. I tricky question. So very simple. So next, is our last term to amar, that is concentration terms, molality. So it is expressed by small m. Okay. So it is same definition, but it's slight difference. It can be defined as the ratio of number of moles of solute present in 1 kg of the solvent. So at ratio to ki ami agor jiman loisu of solution upon base korisu, but molality are defined in presence of solvent. So but in respect of solvent. So mathematically molality m, number of moles of solute divided by mass of the solvent in kg. So it took me kg. So I simply I got represent directly express so W solute, M solute. So this is the ratio of weight divided by molar mass. So that is number of moles of solute. So the weight of the solvent in kg. So molality is expressed by W solute, M solute multiplied by 1000 into W solvent when it converted to gram. So we can find here also the unit. So from this part all we can calculate units, but in this part also we can calculate unit. So here is a gram, unit is gram, molar mass gram per mole, 1000 gram per kg, W solvent in gram. So we already converted, so gram cancel, so F is mole per kg. This is the unit of molality. So it can also express as unit is small m. This simple definition. So we can do the problem. So we take two problems we have to do. So you see the questions, very simple. Actually this questions are very simple already. So it's just given first question. You see 7.4 gram of potassium chloride was dissolved in 100 gram of water. So calculate the molality of the solution. So yat amak ki dia ase. So water is the solvent and potassium chloride is the solute. So at a solution ami banai thoi dia ase, tar amak ki dia ase solvent or weight dia ase aru amak dia ase solute or weight. So ami tar he duta data por ami ki ulebo lage solution to molality calculate koribo lage. So we can calculate. It's you just see question 1 on solution. So yat jodi ami sao amar given ki ase ami likhi lobo paru, direct likho ami short form. W solute dia ase amar potassium chloride hoy KCl, that will be 7.45 gram amar dia ase. Similarly solvent dia ase amar W solvent, that is water, will be 100 gram. Okay, so we can convert it to into kg, but it's not, it's okay. So in gram also we can do it. So already all data are present. So molarity we can find. So molality. So you just we know that. Before we have to know the molar mass of solute. M solute KCl. So potassium will be 39. Okay. Plus chlorine will be 35.5. That is will be if we do 74.5 gram per mole. So molality will be W solute.
Please ignore for the background music.
So this is the W solute times 1000 gram per kg divided by W solvent in kg. So mass of the solute will be 7.44 or 7.45 gram, and molar mass of the solute will be 74.5 gram per mole. And the mass of the solvent will be 100 gram, and then we put this value and then subtract. Here we got 74.5 divided by 74.5 mole per kg, and we got the answer 1 mole per kg. So 1 mole per kg is the unit of molality, so it can be also represent 1 mole of the solution. So this solution have the answer will be 1 mole. So this question, this is the homework or home assignment, you have to do it. So question and give the answers in comment box. So 34.2 gram of sugars dissolved in water to produce 214.2 gram of sugar syrup. So this is the solution of sugar in water. So sugar is the solute, water is the solvent. So mass of the solute is present and mass of the solution is present. So you have to find mass of the solvent. Then you got the mass of the solvent. And you already know that so we have here we require mass of the solute and molar mass of the solute. So already we got already in the question it's the indicates the mass of the solute. So you have to find mass of the solvent, molar mass of the solute. So the chemical formula of sugar will be C12H22O11. So you have to find the molar mass of this. So then you put this value in this equation, then you got the molality. For the next part of the question, calculate the molarity and mole fraction of the sugar in the syrup. So mole fraction. So you have to find the number of moles of each component, sugar and water. So already we know that molar mass of the water, that is 18 gram. So in here the mass of the water, that is mass of the solvent. So you have to find from these two datas. So then you put the value and give the number of moles. Both number of moles, when you find, you got the total number of moles, then you find the ratio of the number of moles, you got the answers of mole fraction. So thank you. So keep watching, please subscribe.